Hello and welcome to this lesson. Now we're going to talk about something called hash maps. All right, we've looked at lists, we've looked at sets. The third kind of collection, so to speak, even though it doesn't necessarily belong to the collections framework specifically, but oftentimes people refer to it as a collection, is the map data structure. And the maps data structure, such as hash map, and there's a couple of others you'll look at, such as tree map and linked hash map. A map is basically like a dictionary. If you open a dictionary and flip over to some random page, you'll see that there are words and then there are definitions. Okay, any page in that entire dictionary has the same structure. You got words and then you've got their definitions. That's a map. That's a hash map, specifically speaking, right? The data structure is represented in that format. And oftentimes the structure is referred to as a key value store, meaning keys and values. Keys point to values. So when you have a dictionary, the words point to their definitions. Every word has at least one definition. So the key would be the word and the definition would be the actual value for that particular key. And the dictionary is filled with these sort of entries. So let's go over the actual structure in Java. I'm going to right click here on source and go to new. We'll create a new package and we'll call it lesson 5. And I'm hoping you're creating these lessons as we go along and not just copy pasting the code from someplace, okay? So make sure you're actually creating these classes and coding along as we go through these lectures. So let's go to new class and we'll call this class application, like we've always been doing so far. It's going to have the main method in here, and that's where we're going to test out our new data structure called the hash map. So defining it is going to be very similar to the array list or the hash set. It's just called hash map. It has those angle brackets, and I'm going to fill those out in just a second, but first let's give this hash map a particular variable. We'll call it dictionary. New hash map, like that. Now the important thing to remember about a hash map is every row of data is considered an entry, which contains a key and a value, okay? So like a dictionary, we have words and we have their definitions. So in these angle brackets, we have to first identify the data type for the key, and then we identify the data type for the value. So if we are representing a Merriam-Webster dictionary here, and we're going to put words and definitions in here, what do you think are going to be the two data types that represent that structure? Well, the first one is going to be a string, and the second one is, of course, also going to be a string. Words are strings, and so are their definitions, right? So we're going to do the same here, string, comma, string, okay? And now you could just do Control-Shift-O to do the import. And this also, of course, comes from java.util. Now the array list, the linked lists, the sets that we've been going over, hash set and linked hash set, those belong to the collection framework of classes. The hash map, as well as some other variations of this map that you'll see, they implement the map interface. If you control click this hash map class, notice that it's saying extends this map interface, and notice the K and the V. Any instance of this class that we create, a hash map, is going to have a key and a value, and that's what we're defining here. Right here, we're giving the key to be the string data type and the value to also be a string, right? We can put any data type in here, any complex data type. We can't put primitives, just like array list and hash map. We are not allowed to have primitive data types in these angle brackets, but we can have types that have classes associated with them. And so string is a perfect candidate for this example. So let me close this hash map class up there. So to insert data into this hash map, all we have to do is reference the variable dictionary dot put, okay? It's not dot add, it's dot put. So that's a key difference between the list and the map interface. So over here, if you look at this method signature, it recognizes that we have a hash map of strings. The key is going to be the string, and the value is also going to be a string. So it expects us to put in two string data elements in here. So the first one, let's just say, is the word, since there's going to be a dictionary that we're representing, we'll say the word brave. And the second value after the comma is going to be the definition for the word brave. And I've already copy pasted it out here. I'm just going to copy it and paste it. It's just a definition that I looked up from Google just to make things simple. So this is the key and this is the value. Okay, I'm just going to copy paste this a couple of times so we have a few different words. We have brave. Let's put another word, for example, brilliant. I'll have another word called joy. And finally, we'll put the word confidence. So next thing we need is their definitions. I've already copied them and pasted them somewhere else. I'm just going to bring them over here to the screen and paste them for the respective words. So brilliance definition is going to be this. Joy's definition is going to be a feeling of great pleasure and happiness. And then finally, for the word confidence, I'm going to put the definition as this. Okay, so you got the idea, you got the keys, and you got the values. And together, each one of these entries is referred to as an entry set. We've got the first entry right here with this word and definition, second entry, third entry, and fourth entry. If I wanted to loop over this dictionary, I can use the for each loop syntax that we've seen in a couple of lessons ago. That's going to be for, we give the data type string, and we'll just call it word. Next, we need to give the collection that we're going to iterate over. In this case, we can't use dictionary like that. We cannot do that. If this was a list or a hash set, that's all that would be required. But in this case, we need something called dictionary dot, and we need to invoke the key set method like that. And now we're able to iterate over the keys of this dictionary. We need to specify keys as well as the values for this dictionary that we're looping over. So word is going to be taking place of each one of the keys in this dictionary. This is different than what you saw in the array list or the linked list. In that, you just needed to declare the collection variable. But for this case, we need to actually invoke this dot keyset method. If we were to print out the value for this variable word, let's do that. And now let's hit play and notice that the 4 words are printed. Right? These are the keys: brilliant, joy, confidence, and brave. Notice that there's no order to the way they're printed out here. The keys in a map are sort of like a set, right? There's no inherent order. If we were to use a linked hash set, hash map, we could just do linked hash map. Let me copy and paste that here, and then we would need to import that, Control-Shift-O, and now we've brought in the linked hash map. Now it's going to preserve the order in which this data was inserted. Okay, let's hit play and notice that now it's shown in the order of insertion: brave, brilliant, joy, confidence, in the same order in which the data was put. So that's the difference between a linked hash map and a regular hash map. Similar to how it was with the linked hash set, it preserves the order of insertion. Now, if I wanted to see the actual values for each one of these words, I could do dictionary dot get, and as an argument to this get method, we pass in the actual key. So let's put in the specific word, and now we'll get all of these definitions in the order of insertion because we're using a linked hash map. So let's hit play, and whoops, I have to print out these values, right? So let's just surround this with a print line statement like so, and let's hit play and notice that now we're getting those definitions in the same order as they were inserted. If I get rid of this linked part, then the order of insertion will not be managed, right? It'll just be random. There will not be any inherent ordering for the data. So I've changed this back to a hash map. Let's hit play, and now notice that the definitions are not in any particular order. Now you might be wondering, how do I loop over both of these? Right? In this case, we're just looping over the keys. How could we loop over both of these elements, this pair of values? How could we loop over them together? For that, we need to understand what an entry set is. So if I do dictionary dot entry set, notice this method definition. Let's click on it, and you can hit Control click and notice the comments for this method in the hash map class. You can just hover your mouse over here so that it prints it out in a more reader-friendly fashion. So it returns a set view of the mappings contained in this map. All right, so it returns a set view of the mappings contained in this map. Okay, that sounds a little confusing, but all it's saying is this entry set is both of these together. Okay, it's an entry set, and both of these can now be referred to in this loop, the key as well as the value. So for this for loop, what do we need? Before the colon, we need to specify what data type is this entry set method going to return. And that's going to be map.entry. And then you specify the key and value that we are talking about. You don't need this first part. It's going to be map.entry, and then we give the specific key and value. And that, of course, you can get from up here. So I'm just going to paste that down here and then complete the for loop. And now notice that it is compiling. Now, of course, we need a variable declared here that will be used as the iterator. So I'll just call it entry, because that's exactly what each one of these rows are. These are entries. So to print out the key as well as the value, all I would have to do is do entry.getKey, and I could do the same thing for entry.getValue, just like that. Let me comment out the first part, and now we'll be able to see the key as well as the value being printed with the second loop. So let's hit play, and there you go. We get brilliant, joy, confidence, brave, and their definitions. Again, since I changed this back to a hash map, there is no inherent ordering. It doesn't maintain the order of insertion. There's also something referred to as the tree map. And the tree map basically maintains natural order. And what is natural order for strings? Well, it's alphabetic, right? For numbers, it'll be numeric, 1 to 10. For alphabetical, it'll be A to Z. So if I change this to something called the tree map, now it's going to actually sort this based on the alphabetical order. So let's do the Control-Shift-O to bring in the tree map interface, or class rather. If you want to see the definition of the class, Control-click it. Again, all of these angle brackets with these K's and V's and this question mark, that's going to make a lot more sense later when we talk about generics in great detail. But for now, understand that this tree map is going to sort the keys. Right, it's going to sort the keys in their natural order. That's what tree map is. And for strings, what does natural order mean? That's going to mean alphabetical. So let's hit play and notice that brave is number 1. Second place takes brilliant. Third is confidence. And then finally we have joy. The set data structure that we looked at in the previous lesson also has a variant of the tree structure, and that's called the tree set. Feel free to experiment that on your own, but it sorts it basically in the natural order. So there you have it. We looked at the hash map, the linked hash map, and the tree map. And we looked at how to iterate over this structure. If you want the keys and values both in the same iteration, you use this kind of looping mechanism. Otherwise, you can use something like this where you just get the particular keys. If you want to loop just over the values, let me uncomment this. Instead of .keyset, you could just do dictionary.values. And that will allow you to loop over the values, and this variable word, would take the place of each one of these definitions. Now, if you have your own user-defined type in this in these angle brackets, we looked at in the previous lesson that to order them in any way, you'd have to implement the comparable interface for that particular type. Now, these types are provided by Java, right? These strings and integers and so on. But if you had your own user-defined type, for example, let's say you had a class called animal, if you wanted to have that class maintain some kind of order, you want to make sure implement the compare_to method after implementing the comparable interface. If you forgot how to do that, revisit the previous lesson. Now, one quick thing, if I copy and paste this brilliant again at the end of this dictionary, right? I have brilliant up here, and I'm going to paste it here again, and I'm just going to put some random text as the definition. What do you think is going to be the final value when we print it out? Let me comment out this. So we're going to get the keys and as well as the values, we're going to print them out. So let's hit play. And notice that for the word brilliant, the definition has been changed to just these X's. And this goes to show that this tree map or even a hash map or a linked hash map cannot be used to store duplicates, right? It makes sense, right? If you're having a key value type of situation, how would you have one key duplicated with two different values? You can't do that. So if it sees this entry right here, it enters that into this dictionary, goes down, and then finally when it gets to this line, it's going to enter brilliant again, overriding what it had before with this new value, okay? So you can't have duplicate keys in the map data structure. Similar to, the set structure. You can't have duplicates. So it's very important, if you were to have user-defined types as keys for this data structure, you want to make sure that you override equals as well as a hash code method, so that you don't run into a situation where two objects with the same state, same values are repeated in the keys for a dictionary. All right, so play around with this data structure, change these things around, put in integers here or doubles, whatever you want, and test out this structure. Make sure that it's a complex type. You cannot use primitives in generics. So you would have to use the wrapper classes such as integer or double and so on. So play around with it. I'm going to wrap up this lesson. Thanks for watching. I'll see you in the next one.